Artificial intelligence, AI, poses intriguing questions. What is it? And how does chat operate? Delving into the term artificial intelligence, we contemplate its meaning. Does it imply that computer scientists and researchers have harnessed computers to replicate human intelligence, akin to the cognitive capabilities residing in our brains? Contrary to such notions, Wikipedia clarifies that AI is the intelligence manifested by machines or software distinct from human or animal intelligence. It constitutes a field within computer science dedicated to cultivating and exploring intelligent machines, often referred to as AI. The prowess of artificial intelligence surpasses human capabilities. A poignant example from 1997 illustrates this. The advent of AI manifested in the creation of Deep Blue, a robot that outplayed the reigning chess champion, Garry Kasparov. This event shattered the belief that chess, a domain once thought exclusive to humans, could be mastered by machines. AI technology permeates various sectors, from industry and government to science. Notable applications encompass advanced web search engines, recommendation systems, human speech comprehension tools, self-driving cars, generative creative tools like ChatGPT AI art, and superhuman gameplay and strategy games like chess and Go. AI research spans diverse subfields, each honing in on specific objectives and employing specialized tools. The overarching goals include reasoning, knowledge representation, planning, learning, natural language processing, perception, and robotics support. A monumental aspiration in this domain is the achievement of general intelligence, the capability to perform any task as proficiently as a human. An artificial neural network is built upon a collection of nodes, also referred to as artificial neurons, which loosely emulate the neurons in a biological brain. The network undergoes training to recognize patterns, enabling it to subsequently identify those patterns in new data. The structure includes an input, at least one hidden layer of nodes, and an output. Each node applies a function, and once the weight surpasses its specified threshold, the data is transmitted to the next layer. A network earns the designation of a deep neural network if it incorporates at least two hidden layers. Learning algorithms for neural networks utilize local search to determine the weights that yield the correct output for each input during training. The prevalent training technique is the backpropagation algorithm. Neural networks adeptly model intricate relationships between inputs and outputs, discerning patterns within data. Theoretically, a neural network can grasp any function. In feed-forward neural networks, the signal progresses in a singular direction, while recurrent neural networks loop the output signal back into the input, facilitating the retention of short-term memories of prior input events. Long short-term memory stands out as the most successful network architecture for recurrent networks. In contrast, perceptrons employ only a single layer of neurons, whereas deep learning incorporates multiple layers. Convolutional neural networks enhance the connections between neurons close to each other, a crucial aspect in image processing, where a local set of neurons must identify an edge before the network can recognize an object. Generative pre-trained transformers, GPT, are extensive language models rooted in the semantic relationships among words and sentences, a domain known as natural language processing, NLP. GPT models focusing on text undergo pre-training on a substantial corpus, often sourced from the internet. During this pre-training phase, the model anticipates the next token, where a token typically represents a word, subword, or punctuation. Throughout this process, GPT models amass knowledge about the world, enabling them to produce human-like text by iteratively predicting subsequent tokens. Subsequently, a further training phase refines the model, enhancing its truthfulness, utility, and harmlessness. This refinement commonly involves a technique known as reinforcement learning from human feedback, RLHF. Despite these advancements, current GPT models still exhibit a susceptibility to generating inaccuracies termed hallucinations. However, efforts to mitigate this issue through RLHF and utilizing high-quality data have shown promise. Notably, GPT models find application in chatbots, facilitating the formulation of questions or task requests through straightforward text interactions. Tooltester is a website that conducted an interesting survey a few months ago. They provided text to 2,000 Americans and asked them whether they thought the text was written by a human or AI. Surprisingly, 53% of the people were unable to discern that the text was written by chat. They believed it was actually written by a human. This result was obtained using Chat 3.5 version. However, with the advanced version, Chat 4.0, the statistics became even more mind-blowing. 63.5% of the people could not recognize that the text was written by chat. In the late 2010s, graphics processing units, GPUs, increasingly designed with AI-specific enhancements and used with specialized TensorFlow software, replaced previously used central processing units, COPS, as the dominant means for large-scale, commercial, and academic machine learning model training. Historically, specialized languages like Lisp, Prolog, Python, and others were used. In the early 2020s, generative AI gained widespread prominence. Chat, based on GPT-3 and other large language models, were tried by 14% of American adults. The increasing realism and ease of use of AI-based text-to-image generators, such as Midjourney, DALL, and Stable Diffusion, sparked a trend of viral AI-generated photos. Widespread attention was gained by a fake photo of Pope Francis wearing a white puffer coat, the fictional arrest of Donald Trump, and a hoax of an attack on the Pentagon, as well as usage in professional creative art. In 2024, AI trends include powerful AI fine-tuning by defenders and adversaries, cutting-edge applications transforming industries, and key advancements in generative AI. Noteworthy developments encompass multimodal AI agentic, AI open source, AI retrieval augmented generation, quantum AI legislation, ethical AI augmented, working, and the next generation of generative AI. Additionally, AI's role in cyber warfare, potential risks involving biological and chemical weapons, and the ongoing pursuit of ethical AI legislation are focal points in the evolving landscape. Stay updated to navigate the dynamic field of artificial intelligence.